This is a video about the properties that will be on your quiz on Monday. So the first ones I'm going to talk about are the properties of equality. So we have reflexive, transitive, symmetric, and substitution. And the first one I'll talk about is reflexive. So the reflexive property is simply stating that a quantity is equal to itself. So there's only one equal sign, it's only one equation we're talking about, and it's where you have the same exact thing on both sides. So 3x plus 2 equal to 3x plus 2. That's an example of the reflexive property. Or 6 equals 6, or 5x equals 5x. If the same exact thing is on both sides, that's reflexive. Same exact thing. So if I did 3x plus 2 equal to 2 plus 3x, that is not an example of the reflexive property. It is not the same thing. It has to be the same exact thing in the same order on both sides. So 3x comes first here, the 2 comes first here. So it's not the same exact thing. This is actually an example of the commutative property of addition. So it has to be exactly the same thing in exactly the same order for it to be reflexive. So again, saying a quantity is equal to itself. This is a quantity and this is a different quantity. They end up equaling the same thing, but they're different because the 3x comes first here, 2 comes first here. So a quantity equal to itself is the reflexive property. The transitive property of equality involves 3 equations. So that's a hint for the transitive property. So it's saying when you have one quantity that's equal to a second quantity, and that second quantity is equal to a third quantity, then the first and third also have to be equal. So basically everybody equals each other. So I always give the example, if I'm the same age as, let's say, Nate. I'm the same age as Nate, and Nate's the same age as Heather, then Heather and I have to be the same age. So that's the basic example with the A equals B. If A equals B and B equals C, then A equals C. Let's do it with some real numbers here. So I say if 5 plus 3 equals 8 and 8 equals 4 times 2, then then 5 plus 3 is equal to 4 times 2. So you look for what they have in common. Both of these, this quantity and this quantity, both equal 8. So since they both equal 8, they have to equal each other, and that's the transitive property. So I could even throw some variables in there. So I can say if 3x plus 4 is equal to y, and y is equal to 2x minus 7, then we can see that it makes sense that 3x plus 4 would equal 2x minus 7 because they both equal y, so they have to equal each other. So 3x plus 4 is equal to 2x minus 7. And we will use this property a lot coming up when we are solving systems of equations. It won't be for a while, but we will use it. The next one is the symmetric property of equality. And so this one is just saying that if you have an equation like 3x plus 4 equals y, then I could say it the other way too. I can just flip it around, y equals 3x plus 4. So all I'm doing is taking what's on the right side of the equation and putting it on the left side, and what's on the left side and putting it on the right side. I'm just flipping it around because when we work with these kind of equations coming up next chapter, we like to have the y on the left side. So if I have this, I can just turn it around to be this, and it's the same exact thing. So that's the symmetric property of equality. So your hint is, so I say if this, then So if 3x plus 4 equals y, then y equals 3x plus 4. I'm just turning it around. So your symmetric property of equality will always have two equations in there. So I can say, if you got an answer of 4 equals x, well, you can turn that around and say x equals 4. So if like you were solving and had 2x equals 8, and you divide each side by 2, and you get x equals 4, or 4 equals x, you can turn them around and say x equals 4. The fact that you can do that is the symmetric property of equality. The last property of equality is the substitution property of equality. So that's just saying if x equals 4 and 3x plus 2 equals y, then 3 times 4 plus 2 equals y. So because x is equal to 4, anywhere I see x, I can put a 4. So that's a substitution property. I'm substituting in 4 for x. Think of it like a basketball game or a volleyball game. When you substitute in a player, it's usually to be in that position that that player is in, especially in volleyball. It's not always in basketball. But if you're on the right side in volleyball and somebody switches in, they're playing right side. Or if you're in a baseball game and you've got your pitcher and you substitute somebody in for the pitcher, they're going to be the pitcher still. So it could be written like this, where you have if this and that, then this, where you're just simply plugging it in. Or it could be from one side of the equation to the other. So I could say 3x equals 3 times 4. So I don't even have to tell you this part, if x equals 4. If I just tell you 3x equals 3 times 4, you can see that all I did was put a 4 in place of the x. So that must mean x equals 4. So what I did here to get from this side of the equation to the right side of the equation is substituted. A lot of times you're going to see this substitution happen when you're evaluating. So if I have a problem like 3 times 1/3 plus 7. When I'm simplifying this, 3 times 1/3 is 1. That is substitution, but it's a special substitution, and we know that that is multiplicative inverse. But then when I have the plus 7 and then I simplify that to be 8, that's going to be substitution, because in place of 1 plus 7, I put 8, a value that is the same as this value. So when they equal the same thing, they're equivalent expressions. So I could replace 1 plus 7 with 8. That's just simply substitution. So a lot of the times you will see your substitution property of equality in your evaluation problems. That's it for the properties of equality. I'll make another video for the properties of real numbers, which includes your multiplicative inverse, additive inverse, and all that good stuff.